number, I'm mathematician. It makes me so ambitious. My answers are judicious. Calculator never glitches. It's my mission. I get the answer right, and I'll be staying up all night just to check what I write. Mathematicians. 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 Hold up. Check your word. Computing areas, quadratic formula, graphing parabolas. I think they're all so cool. It's my soul.
Alright, welcome back, Algebra 1 students. As we continue on with graphing parabolas, because they are so cool, we're looking at an intercept form this time. So we'll be taking a look at that here in just a little bit. We're going to be looking at graphing these quadratic formulas, or quadratic functions, I should say, using an intercept form. We've already used standard form, we've used vertex form, and now we're looking at intercept form. Let's first look at our cartoon. I have a Garfield for you today. So Garfield walks in, sees the pie, John's, whoo! Sees Garfield checking out the pie. That's my pie, Garfield, hands off. So Garfield keeps his hands off. Ploop! Face first into the pie. Frustrating John, of course. Alright, well, as we look at our intercept form, like I said, we've already gone through standard form, as you can see here. This is our standard form and our vertex form. So we have our standard form here and our vertex form here. Intercept form now, and there's a vocabulary part for you to probably on 267 where you can write this down. Intercept form is this form right here, but you see it down here on the core concept. And what you could write, though, is that the intercept form, it's in this form, the polynomial, it defines a function in factored form. So it's in factored form, so right there, that's what you can write down. Intercept form is in factored form, and the x-intercepts of the graph can be easily determined. So that's what we can see from the intercept form. Again, we see the parabola, the U-shape. This time we're seeing it in factored form. So it's like this. It has an a still. So the a number is still going to be determined whether it's opening up or down. If this is positive, it's opening up. Negative, it's going down. Also, the a number tells you about we talked about the a number pattern, parent pattern. We'll do the same thing here as well. So it still has a number in front of these two parentheses. That's the a number, but inside the parentheses, each one is an x-intercept. It's in factored form, so x minus p, x minus q. They just use the p and the q to represent the two factors. The letters that they chose don't make any difference. I'm not sure why they chose p and q, but that's what they've chosen. So again, we always want to find the vertex first, and that's what's going to be shown here. Vertex axis of symmetry. You can do that now this way with x equals p plus q over 2 or divided by 2. That will give you the x-coordinate of your vertex, kind of like when we did standard form. We did negative b over 2a when we were doing standard form and found the x-coordinate. Then you got to plug it back in to find the y-coordinate. We're still going to need to do that here. Once we find the x-coordinate, we'll plug it back in to find the y-coordinate of the vertex. But just the x itself will give us this dashed line of the axis of symmetry, which cuts the parabola into two equal halves. And you can see, like I said, these factors here are the x-intercepts. It's where the graph's going to cross the x-axis. So graph crosses here at p, here at q, p comma 0, q comma 0, when y is equal to 0. And again, same thing, like I said here on the graph, opening up or down based on the a being positive or negative. All right, first though, let's take a 268 in your journal book. On the first two extra practice problems here, we're not graphing anything. We are finding the x-intercepts and axis of symmetry of the graph of the function. Okay, so there's those two things that we need to find first before we can actually graph the function. So finding the x-intercepts, that's going to be finding p and q. So basically what we're going to do here is, what would we need to do if we plugged in 0 for y? We'll be able to solve this. And basically, since it's in factored form like this, each factor can set equal to 0. So we can kind of start as 0 equals this x plus 2 times the x minus 4. And now using that zero product property, okay, zero product property, we can property, there you go. We can now set each of these factors equal to 0. So we can say x plus 2 is equal to 0, and I'll just put a line there, x minus 4 is equal to 0. Solving each simple equation, we'll subtract 2, x is equal to negative 2, and this one you're going to add 4, x is equal to positive 4. So what are the two x-intercepts? Well, it's negative 2, positive 4, but what we should do is actually write it as an ordered pair. So it's, again, when y is 0, so negative 2, comma, 0. And this one, again, is also when y is 0, 4, comma, 0. So those are our two x-intercepts. We can even think of this as your p and your q numbers as well. And then as far as the axis of symmetry goes, so for the axis of symmetry, just put sim right there, we're going to take these two numbers here. So x is equal to, remember it's p plus q over 2. P and q are the two x-intercepts. It doesn't matter which one is which here. We just know it's going to be negative 2 plus 4 over 2. So our axis of symmetry is going to be this equation. X is equal to, this is going to end up being, well, let's see here, take 2 away from 4, that's going to be 2 over 2, which is 1. So your axis of symmetry is going to be x equals 1. Here's your two x-intercepts. So these are the x-intercepts right here. Just put it like that. Equals those, and this is our axis of symmetry right there, x equals 1. All right, for number 2, you guys can go ahead and try number 2 on your own. Try to do the same thing. Find the x-intercepts, find the axis of symmetry. Go ahead and pause the video to do that on your own, and then play to check your answer. All right, so hopefully you have your x-intercepts. I'm going to go a little bit faster on this one. I'm just going to go straight to the zero product property, setting each of these factors equal to 0. X minus 2 would equal 0, and an x minus 3 is equal to 0. This 3 in front here, this doesn't really make any difference what number that is. You have your two factors. Because if you do the zero product property with this, it's not even a variable. So that's why you only do it with the variables. This one's going to be x is equal to a 2. So this one's going to be, I forgot my 0 there. X is going to equal a 3. So your two x-intercepts should be written as an ordered pair, 2, comma 0. And this one would be 3, comma 0. So those are our x-intercepts here. Equals those ones. I'll put a little and in between. And then for the axis of symmetry, so axis of symmetry, we're going to take x is equal to, again, p over q, so 2 and 3, so it's 2 plus 3 over 2. So that's going to end up being 5 over 2. And you can just leave it as 5 over 2, or you could say 2.5. That's fine too. So x is equal to 5 over 2 is perfectly fine. That is our axis of symmetry. That right there. And then you have your x-intercepts right up there. All right, let's move on. Now we're going to get into some graphing. We're graphing on a coordinate plane. Number 3 and 4, graph the quadratic function, label the vertex, axis of symmetry, and x-intercepts, and determine the domain and range of the function. Okay, so I have some things down here written below. We need to find vertex, p and q numbers. We can look at those. Domain and the range. We'll be writing those out as well. So notice on the graph how I'm drawing the coordinate plane here according to this. It's best if we draw like this. We're going to see it's going to go by 1s on the x-axis. It's going to go by 2s on the y-axis. All right, so the first thing to do here would be we need to know what the vertex is, which is like finding the axis of symmetry as well. So we need to know what is our p and our q number. So here's what we can do. We could solve like I showed you before, find those x-intercepts, but since it's in vertex form here, or intercept form, this is the P and the Q. So you can think of, okay, this is P and this is Q right here, but it's always the opposite of what they are. Because remember, if it was x plus 5, we're going to subtract 5, P would be negative 5. This one's going to be negative 1 for Q. So there's our P and our Q number. And when we want to find the x-coordinate of our vertex, looking for this first one, the x-coordinate of the vertex, that's the same thing as finding the axis of symmetry. So we can say x is equal to P plus Q, add them together. So negative 5 plus a negative 1 over 2. So it's going to be x is equal to negative 6 over 2, and so that's going to be negative 3. So my x-coordinate of the vertex is negative 3, which is also the axis of symmetry, remember? So that's an important equation right there. It's going to go right down through negative 3. So if this is 1, negative 1, negative 2, negative 3, here's my axis of symmetry. You can even draw that kind of dashed line going along there at the negative 3 point. Now to find the y, we need to take this negative 3 and plug it back in. So when I plug it back in here, I'm going to put negative 3 in here for both places, negative 3 plus 5 in this one. And on this one, it's going to be negative 3 plus 1. And they are multiplying each other. So when I figure out this one here is 2, this is going to be, I'll put 2, is going to multiply. This is also going to be negative 2 here, taking 1 away from negative 3. So 2 times negative 2 is going to give us negative 4. So negative 4 is the y-coordinate on the vertex. So that's a very important point to see. So we know how high or low this is going. We know it's opening up here. So we know also this one opens up because the A number is positive 1. A is equal to positive 1. So let's go ahead and plot our vertex first. Negative 3, we already know what that is, and then negative 4. Remember, these are going by 2. So negative 2, negative 4 would be there. Let me use red. So plot a point there. Now your x-intercepts, again, are right here, negative 5 and negative 1. So negative 1 is here. There's an x-intercept. Negative 5 is over here. And they should be exactly 2 away, both 2 away from the axis of symmetry. So according to this, what we can see, since the A number is 1, your parent pattern, remember if you were to go 1 this way, we're going to go 1 square, which is up 1. 2 this way, we're going to go up 2, which is actually 2 boxes up, so that's 4. So you're going up 4. So you're going to go 1 this direction. You normally would go up 1. So we could put kind of a dot here. 1 this way, we're going to go up 1. And then 2 this way, we're going to go up 4. 2, 4. Same thing that way. If we go 3, we're going to go up 9. So it's 2, 4, 6, 8, 9 would be halfway here. You could do the same thing on this side. 1, 2, 3 this way, we're going to go up 9. 2, 4, 6, 8, 9. Remember, I'm just doing the A number parent pattern. So we know our A number is 1. So we would take that, and remember we're going to square it. Remember, it's like A, it's the number squared. Remember, this is A squared, x squared really. So I'll put an x here. X squared times the A. So whatever A is 1 here, and then whatever we put in here, we're going to square. So we put 1 in, we put 2 in, we put 3 in. So when I put 3 in, 3 squared is 9, times it by 1, still going up just 9. So that's our, we can go ahead and kind of draw this from here. Just connect the dots like a U shape, coming down, going back up. We're going to want to put arrows on the ends, and then we're good. Okay, so we graph the function, label the vertex. So here's our vertex, right there. Label the axis of symmetry. This was our axis of symmetry. I'll put A of S for axis of symmetry, maybe right there. The x-intercepts. So here's one x-intercept right here. An x-intercept. Here is another x-intercept. So we're labeling those. We could label them with the actual point that it is. So I can put in the points here. I could say for this one, x-intercept is negative 5, negative 5, 0. This one would be negative 1, 0. Negative 1 and 0. So those are my x-intercepts. Best to label them with that kind of ordered pair. Labeling the axis of symmetry would be x is equal to -3, putting it right there on the graph, so on. Even vertex, we could label it with the vertex. I have it though right here. Domain and range, all parabolas. Any U-shaped parabolas are going to be all real numbers. All real numbers. And the range is right here. It's greater than or equal to, so y is greater than or equal to the y-coordinate, which is -4. There's our range. All right, for number 4, for P and Q, it's easy to see those. The P, remember, it's opposite of what you think, so 3 and 1. So 3 and a 1 for P and Q. Your vertex here, we'll find the P, so remember, x is equal to these two adding to each other. Let's go and put that up here again. Just x is equal to P plus Q over 2. That's our like little formula there. So it's going to be 3 plus 1 over 2. So x is equal to 4 over 2, which is 2. So x is equal to 2. That's our axis of symmetry. It's also the x-coordinate, which is 2. We're going to put 2 in here for x. So we can think of this as, this is 2 here, 2 minus 3. So we're going to -4. 2 minus 3 is -1. This is also 2 right here. 2 minus 1 is +1. So this is all going to be 4. So 4 is our y-coordinate. So -4 times 1 is 4. So negative times negative, that would be 4. 4 times 1 is 4. So let's go ahead and plot that point. So again, the x-axis by 1s, y-axis by 2s. So 2 and then 4 is up. We know this one is, a number is -4. So it's opening down. It's going down. Going down from here. Where's our x-intercepts? Where it's at 3 and 1. So there's a 1 at 1, there, and there's 1 at 3. Right there. So we can use the A number pattern to maybe get a couple more points. We could see if I went, 1 this way. We went down 4. Okay, so remember A number pattern. So 1. So again, it's -4 is our A. -4 times the number square that we go. So we go 1. We can put in 1 here. That's going to be just going down 4. So that's what I did. Went 1 to the right or left. I'm going to go down 4. If I go 2 to the right or left, if I put 2 in here, that's going to be 2 squared is 4. 4 times -4 is -16. So I have to go down 16. So I'd be going down 2, 4, 6, 8, 10, 12, 14, 16 puts me right here. Again, go 2 this way. I'm going to go down the same amount all the way down to here. So it's a very thin graph. We can draw our axis of symmetry. I'll kind of highlight that here in green. So it's going through. Here's our axis of symmetry going through that. And let's go ahead and draw our parabola here. It's coming up. Kind of catch it. There we go. And U-shape coming around, going back down. Arrows in the ends. Okay, mine's not very perfect, but you got the idea of how it's shaped. And we can go off of our domain, again, all real numbers. We know that. For every one we see, it's going to be that. Everything that opens up or down. Range, it's going to be y. Since it's going down, it's going to be less than or equal to the y-coordinate, which is 4 in this one. And we can label these. We can say this is our x equals 2 for the axis of symmetry. We can say this is going to be 3, 0 for that x-intercept. This one is 1, 0. Even the vertex, you can label it as a 2, 4 right here. So you can label them with those just ordered pairs and what they are. All right, let's move forward to looking at 5 and 6. So 5 and 6, continuing on. So what we notice here is that it is not in intercept form. So we have the option, we can graph it in the form that it's in. This is on number 5. These are kind of both in standard form. This could actually be any form, in fact. So x squared minus 4. This could be vertex form. This could be standard form. We could change it to being intercept form, which is what I want to do just because we're talking about intercept form. So I would probably, if I was just going off of this one, I'd probably do this one in vertex form and not worry about P and Q. So I would probably do that. So if I'm going to do this in intercept form, the reason why we can do it intercept form is because we have a difference of 2 squares. And we can factor this. Now we've already factored problems in the past. We've factored a difference of squares in the past. So we can say that this here is the same thing as saying this. We can say 2 binomials. We can say x plus 2 and x minus 2. So there's our P and our Q. It's a positive 2, negative 2. So positive 2, negative 2, doesn't matter which one's which. And so then when we do for our vertex and just do the P over Q, so negative 2 plus a positive 2, P and Q up there, adding together. So that's going to be actually 0. So we're going to see 0 over 2, which is 0. So x is equal to 0 on this one. That's going to be your axis of symmetry. It's our x-coordinate on the vertex. If you plug 0 in, and you can plug it in even back up to here, 0 squared is going to be 0. This is your y-coordinate is negative 4. So it is negative 4 there. Let's go ahead and plot that one 0 and then negative 4. I didn't write anything on here. We're going to go by ones. Everything is going to go by ones. So negative 4 is down. 1, 2, 3, 4. So this is going to be our vertex right here at 0, negative 4. P and Q, so we're going to see positive 2 right here. This is our 2, 0. 1 x-intercept. Negative 2 is over here. So negative 2, 0, another x-intercept. And just x is equal to 0. This ends up being this y-axis actually is our axis of symmetry. So going off the parent pattern is just a 1 here. So as I go 1 this way, 1 squared is 1. We're going to go up that way. Go up to here. And if I go 2, 2 squared is 4. We already got those. So if I go 3, 1, 2, 3, we're going to go up 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9 takes me all the way to the top. So there's a point that's going to be right there at the top. 3 this way, also going to go all the way to the top. And so now we can just combine, connect those dots together, creating our U shape. That one didn't start off very well. And come on up. Alright, we'll just draw arrows on the ends, and there we go. So that one kind of comes down a little bit more like that. Alright, the domain is all real numbers. And the range is going to be y. Since we're going up, it's greater than or equal to the y-coordinate is at negative 4. So negative 4 there. That's our range. Alright, if we look at number 6, also in standard form here, this is definitely not vertex form, it's only standard form. So we could graph it with the standard form. We could find the vertex with negative b over 2a. But I'm going to change this into, I'm going to factor this. So we'll say f of x is equal to 2 factors. I'm going to factor it with the simple method. We've done that before, where we put the x's up front. And then 15, 2 numbers that multiply to give me 15. That subtract to give me a 2 would be 5 and 3. So 5 minus 3 is going to give me 2. They're different signs. The bigger number is going to be positive from that 2. So positive 5, negative 3. So there's our P and Q. So remember, it's opposite of what you see. So you can say negative 5 for one of them, and the other one's going to be positive 3. Again, it doesn't matter which one's P or Q, it just kind of helps us keep it organized. Now if we want to find the vertex, again we're going to do x is equal to negative 5 plus 3 over 2. So that's going to end up being, taking 3 away, that gives me negative 2 over 2. So negative 1. X is equal to negative 1. That's the x coordinate. plug that in. We can plug it back in either up here or we can plug it in inside here. It doesn't make any difference. If I plug it into each binomial here, -1 here will make this a 4, and -1 here will make that a -4. So that's going to be -16. So -1 and -16. Let's go ahead and plot that point. Now we can see here we got going by 1s on the x, going by 2s on the y. So go -1, that's going to be this way, 1 to the left, and then 2, 4, 6, 8, 10, 12, 14, 16 is way down here. So there's my vertex. The P and Q's are the x-intercepts. So I got 1 at a 3. So 1, 2, 3. There's 1 here. This is going to be 3, 0. You can label it there. And then -5. So 1, 2, 3, 4, 5. Here's another one. And this one's going to be -5, 0. Our A number is still going to be 1 here. So it has that same parent pattern is exactly the same. So if I go 1 this way, I'm going to go up 1. So I'm going to go up 1, which actually is just half a box. Go left 1, half a box up. If I go 2, I'm going to go up 4, which is 2 boxes up. 2, 4. 2 this way, same thing. And if I go 3, 1, 2, 3, I'm going to go 9 up. So 2, 4, 6, 8, 9 would put me here. Same thing this way, 1, 2, 3. And then you go 2, 4, 6, 8, 9. Remember, 3 squared is 9, that's why I'm going 9 up. You don't have to worry about multiplying by A because A is 1. You only need to worry about multiplying by A when A is something different than 1. So that gives you all the stuff. You can see it all works out here. So as we come down, I'll draw this one a little bit better. This is very hard to draw with this thing. So coming down, especially the U shapes. And we come back up. Not too bad on that one. I think it's when I go too fast that it gets a little crazy. Our domain, you know, all real numbers. Range is going to be y since opening up, another greater than or equal to -16 on this one. Graph is greater than or equal to -16 on the y-axis. Yeah, it's just where is the graph on the y-axis? It's greater than or equal to -16. Our axis of symmetry, we didn't really label that one. Let's go ahead and put that in here. So this would be my axis of symmetry, kind of coming down like this. And that is x is equal to -1. So x equals -1 right there. All right, so let's take a little break for our joke of the day. Why are fish so smart? Why are fish so smart? Maybe you never thought about that before. Why are fish so smart? Well, it says because they live in schools. So great. They live in schools. Wow. It'd be kind of sad to live in school, wouldn't it? You have to actually live in your school. Boy, I'm glad I live in a house in my home. All right, moving on. All right, factors and zeros. That's our core concept on page 267. What we're going to notice here is that they are one and the same. For any factor, like x equals some number, x equals 3, x plus 2, something like that, a polynomial, the n is a 0 of the function defined by the polynomial, so which means a 0 of the function is an x-intercept. Okay, so just keep that in mind. We're talking about a 0 of the function. 0 of the function there is the same thing as saying an x-intercept of that function, which is, one of the solutions to the function. All right, on page 269, we see 7 and 8. It says find the zeros of the function. So what we need to do is factor this to get it into factored form and see what those factors are. The factors are going to be our zeros or our x-intercepts. So in this case, we're going to start off with y is equal to, factor the 6 out, first of all. That's going to give you x squared minus a 1. That x squared minus 1 is a difference of 2 squared, which can be factored again. So we can see two binomials, x plus 1, x minus 1. Always recognize these difference of 2 squares. They come up every now and then. Very common. Perfect square term here, perfect square term with a minus in between. Special binomial. So there they are. What are the two zeros? Find the two zeros of the function. They are right here, the p and the q. The p and the q numbers of our function. So that's going to be positive 1 and negative 1. Those are the zeros of the function. Positive 1 and negative 1. Number 8, we want to factor the trinomial. So y is equal to, factor it to two binomials. With the simple method, it only has an a equals 1, so we could just start off with x, and you ask yourself that question about what two numbers multiply to give you 20, and there could be a few of them, like 2 and 20, 4 and 5, and so on, but those have to add to give you 9. So 2 and 10 don't add to give you 9, but 4 and 5 do. So 4 and 5, they're both the same sign, they're both going to be positive. And so there you go. This p and q. What is the p and q of the function then? Remember, it's opposite of that. It's like if you were to do x plus 4 equals 0, subtract 4. So it's going to be a negative 4, and this would be negative 5. There's our zeros of the function. And we're trying to find the zero or zeros of the function. And that's all it is. Just factor it and basically find out what those two p and q's are, or the p and the q are the zeros of the function. So zeros of the function are the p and the q. All right, let's move into 9 and 10. We're going back to graphing again. It says use zeros to graph the function. So here we're going to use those zeros, just like we were doing a second ago, to graph the function. And some graphs don't have to be, so detailed with all of the points on them. It can be fairly basic just to get the idea of the function. So again, we're going to factor this. So what I want you to do, I want you to try factoring number 9. First factor that. Go ahead and pause the video. I've done it for you on number 8. I want you trying to factor number 9. Do that on your own. See if you can get this into two binomials. And that way you can find the p and q. Fill in the p and q down here at the bottom. We'll put that down below the graph. So pause the video, factor it, and identify p and q for number 9. All right, so let's go ahead and factor with simple method. You should have got this. Should have been f of x equals two binomials, x and x up in front. Two numbers multiplied to give you 10 is 2 and 5. 2 and 5, they will subtract to give us a 3. So the bigger number's got to be negative, which means the smaller one's the opposite. So our p and q, negative 2, positive 5. Remember, it's the opposite of what they seem, because remember, you're going to be subtracting 2, adding 5. So negative 2, positive 5. For your vertex and your axis of symmetry, remember, x is equal to. So what I want you to do now is basically finish this one off. So find the axis of symmetry and the vertex, plot the vertex point, plot the p and the q, the x-intercepts, and then try to graph it from there. And then I'll show you that answer in just a minute. So finish up number 9 and then play it to check your answer. All right, our p and q here, it's going to be negative 2 plus a 5. Which is unfortunate because we're getting an odd number on top. It's going to be 3 over 2. And it's a little unfortunate. But we can still work with it. I would probably prefer seeing it as a 1.5. Like that. So that is our vertex for the x-coordinate is 1.5. Now if I plug that in, either up in here or inside, it's probably easier to put in here, I think. 1.5 plus 2 would be 3.5. So I'll put it up on top here. 3.5 is going to multiply. If I take 1.5 away from 5, that's going to be also negative 3.5. And so here, if I use my calculator, And I do 3.5 times 3.5. That's 12.25. And it's going to be negative. So that's, you're going to be thinking, why did you give me a hard one to do on my own? You can do it just fine. Alright, so if I plot this point, so going by ones this way, so 1.5 would be here, and then negative 12 are going to go down, and it's going by 2, so 2, 4, 6, 8, 10, 12, and then a little bit more for 0.25. So right about in there. Like I said, it doesn't have to be too elaborate. We got our vertex. It's not asking us to label anything. P and Q is your x-intercepts, so we know it's going to be at a 5. 1, 2, 3, 4, 5. So right here. And at a negative 2. 1, 2. So basically just using that, we can just draw a U-shape, kind of through this. I'm just going to go through that. So I'm going to say it's going to go up, kind of this way, and up that way. The A pattern would be, you can use that A pattern. We're going to go 1 each way and go up 1, 2, go up 4. So it's pretty close. So as long as you get the idea, it's opening up, as you can see, and so on. All right, so number 10. Oops. Number 10, I'm going to go have you try this one on your own. So after we've done already these now several times, it's already in factored form. You have an A number of negative 2. So pause the video, graph the function, use the zeros to graph the function for number 10, and then play to check your answer. Alright, so if you're checking your answer here, we should have a P and Q, so it's going to be, this one's going to be negative 3. It's always the opposite of what you see. This one's going to be positive 1. There's our x-intercepts. For a vertex, x equals. Taking these, you're going to say basically negative 3 plus 1 over 2. So x is equal to negative 2 over 2. So that's going to be negative 1. So negative 1 for the x-coordinate. Plugging that back inside here, we're going to start off with a negative 2 times, take 1 away from 3, that's going to be 2 in this one. Negative 1 is going to make negative 2 here. So 2 negatives is going to make the number positive. 2 times 2 times 2 is an 8. Positive 8. So it's going to be an 8 there. So negative 1, I'm going to go 1 this way and then go up 8. 2, 4, 6, 8. Remember, these are going by 2s this way. And it's opening down negative 3. So 1, 2, 3 is one x-intercept. Positive 1 is the other x-intercept. And let's just use that. We can use the go down 2. We're going to go down, we're going to go 2. So it's going to be about right there. About right there. That's kind of what we're aiming for. But so something like this. And that's all we need. There you go. So we graphed the function using the zeros. We just got the vertex point and the 2 zeros, and we got the idea of this function. So we know it's U-shaped, and we know it's opening down. We get the idea of what it looks like. All right, just 2 more problems. On these next 2, our last 2, 11 and 12, we're going to continue using zeros, but notice it's getting a little bit bigger. We have an x to the 3rd on this one. These are not U-shapes. So we're going to see these are a little bit different shaped, but we're still going to look for the zeros of the function. So for number 11 here, we're going to factor this. We're going to factor out an x first. So we're going to factor, I'm going to kind of put it over here. So f of x equals, factor out x, and now we have x squared minus 9, which is a difference of 2 squares. So f of x equals, x is still there. It's going to be x plus 3 and x minus 3. Okay, so we have all these different zeros. So here's our zeros here. Zeros are where it's going to cross the x-axis when y equals 0. So this would be x is equal to 0. So each one, if you set each one equal to 0 separately, maybe I'll show you that first. So let me do that. So if we just use zero product property, x is equal to 0, x plus 3 is equal to 0, and x minus 3 is equal to 0. And so obviously we can see this one's going to be 0, this one's going to be negative 3, and this one's going to be positive 3. So there's our three zeros. Let's go ahead and plot those here. So we put 0 right there in the middle, negative 3 and positive 3. So 1, 2, 3 this way, 1, 2, 3 this way. All right, so obviously it's not a U shape, remember. What it's going to be is more like a roller coaster shape. So it's going to kind of come up and through here and up through there. So it's going to look more like this, like that shape. So you can see it's a roller coaster shape coming up. Eventually it turns the corner up here, comes down, turns the corner again, and goes back up. So much more like a roller coaster going across your graph. You guys can go ahead and just kind of plot that. You can see where it kind of hits up here is kind of where it says go 1, 2. So at negative 2, we're at 10 right here. So right there you can see it's if at negative 2, that point's going to be right at 10. So there's this going by 4, 8, 12. So 10 would be halfway in between here. Same thing's down here. At positive 2, it's going to be at negative 10 there. So it's pretty close to where it turns at that negative 10 point. Number 12, let's go ahead and factor this one. We need to see that x is in common, so we're going to factor out an x first. Put it kind of over here. So f of x, so I'll do in blue. So f of x is equal to, factor out the x first. What's left would be a 2x squared. Actually, no, wait a minute. Hold on. I got to factor out a 2 as well. Notice 2, 12, and 10, they all even. Got to factor out 2x. And so that leaves me with just an x squared. And then minus a 6x. And then plus 5. Just divide each of those by 2. So we get 1, 6, and 5 now in there. This now should be able to factor to two more binomials. So f of x equals still 2x here. And then our two binomials start off with x. Two numbers that multiply to give me 5 will be 5 times 1, and they have to add to give us 6. So that's why I chose 5 and 1. It's the only option we had anyways. They're going to be both the same sign. They're both minus. So using that zero product property, so we're going to say 2x is equal to 0. And then x minus 5 is equal to 0. And x minus 1 is equal to 0. So for this one is going to be 0. This one's going to be 5. This one's positive 1. So those are our three. They have 3 on this one. Again, it's not a U shape. It's going to be more like the roller coaster again. So we can see right here it's going to go through 0 again, just like our last one did. And there's 1 at 1 right here, and 1 at 5. So 2, 3, 4, 5 right here. So it's going to be a roller coaster, kind of doing the same thing, going through there. It'll look more like that. So as it's coming up this way, it goes through the 0, turns very quickly, turns right here. So basically at a half, and at a half and 2, it's going to turn, come down all the way down to down here, where we are basically at, looks like 3.5, and what is this going by? This is going by 4s also, so it's pretty far down there. So it's negative 4, 8, 12, 16, 20, 24, 26 about. So pretty far down there. And then it turns back up and goes to our other x-intercept. All right, so go ahead and draw those kind of roller coaster graphs on your paper. And that's it then. Using intercepts, we can kind of get an idea of how some of these are going to go. Now these ones right here on 11 and 12 are really going to be go into more depth in Algebra 2. You'll see these a little bit more in Algebra 2. They'll go into definitely more depth on these functions. These are more polynomial functions. All right, guys, until 8.6, I'll see you then. Have a great rest of your day.